Hello everyone, this is Xiu and today we're going to have a look at problem set 6, question 5. There is a uniform ball of radius r rolling between two rails without slipping, and the distance between the two contact points is d. Part A asks us to find the speed of the center of mass of the ball, given that its angular velocity is equal to omega. Part B asks us to find the speed of the center of mass of the ball if it rolls down a ramp of height h without slipping. Also, what would the speed be if we were to replace the ramp with the rails from Part A? In Part C, we have to explain which one in Part B is smaller and why. Firstly, we may find the radius of rotation for the contact points using Pythagoras' theorem. And we find that the smaller radius r prime is equal to the square root of r squared minus d squared over 4. Since the ball rolls without slipping, the contact points have no relative velocities to the rails. Therefore, the rotational velocity and the translational velocity must cancel out for the contact points. So the speed of the center of mass is equal to square root of r squared minus d squared over 4 times omega. For Part B, we first let the gravitational acceleration be negative g and the mass of the ball be m. We know that the moment of inertia of a uniform solid ball is equal to 2 over 5 times mr squared. So the rotational kinetic energy is equal to a fifth time mr squared times omega squared. Since the ball is stationary before rolling down the ramp, the initial kinetic energy is equal to 0. The change in gravitational potential energy is equal to negative mgh. Since there are no non-conservative forces acting on the system, mechanical energy is conserved. By solving the equation, we get that the speed of the center of mass is equal to the square root of 10 times gh over 7. If the ramp is replaced by the rails, we have to change the omega of the rotation from the previous equation. Solving this new equation, we get that the speed of the center of mass is equal to the square root of 10 times gh divided by 5 plus 2 times r over r prime squared. We may also expand out the r prime squared and get this clumsy formula. Since the radius of rotation for the ball on rails is less than that for the ball on ramp, the angular speed would need to be larger to achieve the same linear speed, since v is equal to r times omega. So the ratio of rotational kinetic energy to translational kinetic energy would be higher for the ball on rails. The two systems have the same total kinetic energy in the final state, so the translational kinetic energy for the ball on rails is less than that for the ball on a ramp. In conclusion, the speed of the ball on rails is less than the speed of the ball on ramp. This is the end of our question. Thank you for your time.